Hi everyone, welcome to my YouTube channel, and today let's talk about the last problem of our paint house series. So remember if you go back to my video, I had talked about like two problems from the paint house, and this is the last problem in the series. So let's look at the problem. Okay, so this is our problem. So how many states do we have to consider? Well, we have 3 states to consider, right? So we have to know the house, like which house are we working on. So there will be the index of our house, and we also have to consider how many neighborhoods we have made so far. So remember we are given a target number where if the number of our neighborhoods exceed that target number, then that's not valid answer. So that's something that we have to keep in mind. We have to know the color we just painted the house before. Let's consider 2 cases, right? So we have our first case is when all the houses are not painted. Our second case is when some of the houses are painted. So let's look at the first case. So here we have the case where all the houses are not painted. Here is our houses. So we are given this array and all entries are 0, 0, 0. And one thing that you have to keep in mind is that the index for our color is, so colors are one index. So it starts from 1, 2, 3 all the way to n. So that's something that we have to keep in mind while our houses, while the index of our houses is 0 index. So we have to consider 3 states. Why shouldn't we write something like this? 0, 0, 0. The first entry in like inside our parentheses is the index of the house. The second entry is how many neighborhoods we have seen so far, and then the last entry is the color we just used. In other words, so if we have 0, 0, 0, what does that mean? That means initially we are on the first house, and before this first house we obviously have no neighborhood, and we also cannot possibly paint the color, right? So we have 0, 0, 0. Our first color is red, our second color is yellow, our third color is blue. So that's the notation for this example. So we have 0, 0, 0. On the first house we can paint red, yellow, blue. So we paint red, that's our color 1, yellow, that is our color 2. The third case we have blue, so that's our 3, number 3 here. So you see that this one 1, 1, 1. So 1, 1, 1. What does that mean? At this state 1, 1, 1, this means we just painted our first house with red and we have formed one neighborhood, right? Just this guy itself, and we are on the next guy, right? The next iteration. Now look at here. So from here we can try red, yellow, blue again. So we have first one would be the red, the second one would be yellow, and then the third one would be blue. So we have how many, and then we notice that we are painting our second house with red, so that's why we have 1 here. And notice that because this one and this one, they are the same, right? The previous color and then the current color, they are the same, so we do not change the number of neighborhoods. So our second entry stays the same. Our first entry is incremented by 1. The last color we just used is still the same. However, if you look at here, it is changed, right? We had 1 neighborhood on our first house, but on our second house we have 2 neighborhoods, right? This one and this one. And then the last color we just used is yellow. Same here, we have 2, 2, 3. That means we just used blue on our second house, and since our current color, which is 3, is not equal to 1, so we have to increment our number of neighborhoods by 1. So you see that our second entry is incremented by 1 from 1 to 2. We keep doing this until we hit what? When this is 3, then that's where we have to stop. But also that's not the only condition that you have to check. We have to check that this first entry is equal to the length of house, that's 3. And also we have to check that the number of neighborhoods are equal to the target number. Once those 2 conditions are satisfied, we return 0, and then that's the base case for this problem. This one is, I use both top-down and bottom-up approach, but top-down is much simpler. So this is one of those cases where top-down is simpler, because if you are working on the matrix, then you have to consider all those boundaries value, and that could get very confusing, especially if you are in an interview setting where you have a like say 30 to 45 minutes. So if you are given that time pressure, then I think for this kind of problem where you have like three-dimensional matrix, DP matrix that you have to consider, then I would say like try top-down approach, because base case are simple, as I will show in my codes later. So that's something that you have to keep in mind. And for this one, 1, 1, 2, you do the same thing, right? And then for 1, 1, 3, you do the same thing. In this slide, we will look at this one more carefully. So we have, this is what's going on, and this is the code for like this step where all the houses are not painted and we are moving from one state to the other. Let's take a look at this 2, 2, 2. Now, obviously, this is some slice of my full code. So if this part doesn't make sense, you can go to the part where I show all of my code, and then you can follow this part. But for now, just take my word, and just so let's look at this problem in more detail. So we have 2, 2, 2. This is what's going on here, and then we want to move to the next part, right? We have to still paint this third house with color, and we have red, yellow, and blue. So that's what we can do. Here is what's going on here. We try all the colors from 1 to n+1, and we see what's going on here. So right now here we have a 2, 2, 2. We try this color. So we first try red, since red is not. So if we pick red color for this, the third house, then our next color will be 1, and 1 is not equal to 2, right? So we have this case. So this is our case, and then we try this one. So temp result in this case is set to infinity, like something up here. That's because we are taking the minimum, and so that's one trick that you can think about it. If we are choosing, say, if we are taking the maximum, then we choose temporary result to be negative infinity. But in this case, we are looking at minimum, so we set that equal to positive infinity. And as you know, when something is positive infinity, we know that that's the case where it is impossible to happen. Let's look at this code. So we have 2, 2, 2. That's what's going on here, and we have to pick this color. That will be given by cost of 2. So notice that cost and house, they are 0 index. When I is equal to 2, that means we are looking at the third position, right? And then the next color will be, so in this case, red is 1, but remember the cost and house, they are 0 index, so we have to subtract that from 1. So we have cost of 2 and 0. That will be cost of painting the third house with red, so that's this guy, plus we have to move to the next. That will be paint. They will be given by 3, and 1, right? In this case, since this is equal to 3, we will backtrack. We will return 0, and this part will become 0, and we will just have this one. But that's something that you don't have to worry about it for now. Let's look at this one. Notice that this one is impossible because we have target is 3, right? That's the number of neighborhoods that we want to have. In this case, we have 3. In this case, we have 2, right? If you pick yellow for the third house, then we only have 2 neighbors, right? Because 2 and 2, they are the same. So this 2 and this 2, they are not they are the same. So we do not increment our second entries. So second entry stays the same. We have 3, 2, 2, and this is our this is not valid. So for this case, when we are working on our third house, we will return positive infinity because that's something that this is not allowed. We return this with positive infinity, and this one is also valid answer, right? We have 3 neighbors, and in this case, we have to find the cost of painting the third house with blue, and that will be given by this cost of 2 and 2. That's what's going on here, and that's the case for when houses are not painted. None of the houses are painted. For the cases of when some houses are painted, it's a little bit tricky, but let's look at that example. So here we have houses array given by this 0, 2, 0. That means our second house is painted with what color? With 2, yellow. So that's why we have this one. So that's why we have the middle guy is color yellow, and in this case our target value is 2. That means we can only have 2 neighborhoods, and we have 3 colors to choose from. Now let's look at this. Starting from here is still the same. Like, don't worry about this part. Just pay attention to this guy. So we start with 0, 0, 0, and then we pick the colors, right? We choose the color to paint the first house. That's this guy. And then we paint this one with red, paint this one with yellow, paint this one with blue. And still the same, right? Nothing's changing. It's still the same from this guy, 1, 1, 1, 1, 1, 2, 1, 1, 3. Everything is the same. However, the next part is different, right? This one is already painted, and we cannot choose like 3 colors and try to paint that one, because overriding, we cannot paint already painted house again. So we cannot override this. That's why this case cannot happen, and we should not consider this. Same for here. We cannot paint the second house with blue color, so we cross that out. The only case we have is yellow, so here it is, and we only have 2, 2, 2. So if you look at this code, if current color, which is the house of ith house, so in this case current color will be equal to house of 1, which is 2. If current color is not equal to last color means that in this case is 1, then we have to do this, right? We have to add, so we increment our house index. We also have to increment our neighborhoods, number of neighborhoods, and then our current color in this case is 2, so we just put it there since they are not the same, right? So in this case, last color is red, so that will be 1, so last color is 1. Our current color, which is given by house of 1, which is 2, so they are not the same. So this is how we do this. We increment the house index, we increment the number of neighbors, and the color we choose will be the current color, 2, yellow. Now from here to the next one, we can only try, what can we try? So, and then from here, and then from 2, 2, 2 to next one, this is what we get. How about we look at from this one? So we have 1, 1, 2, and from 1, 1, 2, the only possible cases is 2, 1, 2, right? So same thing here. We increment our house index. So from 1 to 2, that works. Now look at this one, neighbors plus 1. Well, we cannot increment this, right? Because our last color in this case is yellow, which is 2. Our current color, which is 2, since they are the same, we do not run this if statement. We go to this part. So we have neighbor, so number of neighborhood stays the same, nothing is changed, and this guy third entry will be our current color. So that will be house of I. And then from here we do the same thing. In this case, from here we will be looking at this guy, this code. So that's what we do. We try 3, 2, 1, 3, 2, 3, and these answers are all valid because target is 2. In this case, when first entry is 3, which is equal to the length of house, and when the number of neighborhoods are equal to target, then we return this guy, right? So we will return this, we will return this, we will return this, and then we take the minimum of all those numbers. So that's the key idea behind this problem. And if you look at my code, so this is what's going on here. I know it looks a little bit complicated, but just bear with me. So these are the base cases, and if neighbors, so number of neighborhoods are bigger than target, then we return the maximum. That's because this is not possible. So impossible case, remember, whenever we are in the dynamic programming, there will be some states that are not simply possible. In that case, you either return negative infinity or positive infinity, depending on whether the problem is asking for minimum or maximum. In this case, it is asking for minimum, so we return positive infinity. Alright, so that's for this case, and this is the case when the conditions are satisfied. So we are on the last house, and then we have exactly target number of neighborhoods. In that case, we return 0. For the other case, say when we are on the last house and the number of neighborhoods is not equal to target, then that's another impossible case. Or in that case, that's not technically impossible. That's just the case that we do not want to consider. So we return maximum. All right. So that's this part. And then the next part is if this guy is not in our memoization table, what does that mean? This means we have not seen this combination. We have not seen I, comma neighbors, comma last color. If we have seen it, then we will just return it, right? But since we have not seen it, we have to define this. And so that's what's going on here. Current color will be house of I, like ith. So there will be I minus 1 house, right? Because house is a zero index array. Now we check if current color is equal to 0, then we do not have to consider this. However, if the current color is not equal to 0, that means if ith house is already painted, then we have to consider this case, right? We have to consider this case. So that's for this part. And then the other case is that if this is not painted, then so that's for that case. And then we have to set that our temporary result equal to positive infinity, and then we have to run the case for when all the colors are when the houses is not painted, then we have to try all the colors, and that's what's going on here. For next color in range of 1 to n plus 1, we check this, and then we take the max. We keep updating our temp result using this minimum quantifier, and then once we exit this for loop, we will set I, neighbors, last color at memoization table equal to temp result, and then we simply return this. So I know it sounds a little bit complicated, but I really want you guys to try very simple example and see how this code works. So my advice is try not to work say more than so try m equals 3, so you only consider 3 houses, and say target is 2, 3, whatever, right? So consider try to work on your example and see and then I think you can see this code. So we put 0, 0, 0 as our parameters for our paint function, and then we return that value, and then we set that equal to result, and then we check if result is equal to positive infinity, then we just return -1. Otherwise, we return result. Alright, so that's for this, and let's run the code for this problem. Alright, so this is the code for this problem, and my code is exactly the same that you just saw, and let's try to run this. Yeah, so that's for this code, and so I don't know why I got this huge big delta between these two, because I just run exactly the same code, but that's the case with the Leetcode. And yeah, anyway, that's for this video, and if my video helps you guys understanding this problem, please give me thumbs up and subscribe to my YouTube channel, and see you next time. Bye bye.